Now start the System Software and Operating System Lab series. So we are in the exercise 7 lab 7 program, which is a actual lab program of operating system. So 7th program is to develop a C program to simulate the working of shortest remaining time scheduling algorithm and round robin algorithm. So for this we need a introduction of operating system. So first we'll see the introduction, then the types of scheduling algorithm, then we'll move for a shortest remaining time and a round robin algorithm. So initially we'll check with the introduction part of operating system. So operating system is a program which manages the computer hardware and also which controls and coordinates the use of the hardware among the various application programs for the various users. So operating system is used for multi-users also and single user also. So here these system programs will be managed by one of the processes. So here whenever the task is running, then the task is created by a sum of the processes. So what is process now? So process is a program in execution. Process is under execution. So this process executes. Whenever it starts execution, it changes the state. So there are different stages of a process. So the stages of a process are new state, running state, waiting state, ready state, and as a terminated state. So new state is a process being created. Then running state is nothing but instructions are being executed. Then waiting state, the process has to wait for some event to occur. For example, a interruption, or it can be interrupted by some other routine calls, or the program has to be aborted. Something like that, it has to wait for the event to occur. Then ready state. So the ready state is a process is waiting to be assigned to a process. Process is waiting for the CPU to assign it. Right? Then terminated state. The process has finished execution. Now we'll see the state diagram. So state diagram of a process which indicates 5 states of a process. New state, which is nothing but a process is being created. Then once a process is created, it has to be ready for the execution. So it will admit into the new state as a ready state. Then once the process is in ready state, it will be passed to running state. Then only it can start its execution. Right? Once the process start executing, then if in between, if the CPU interrupted by some of the interrupt service routine call, then the process will be in waiting queue. It has to be sent back to ready, then it will be in waiting queue for the process to allocate, right? So once it is in waiting queue, then IO has to be happened, or a event has to wait for the event to finish, then it start its execution. So IO event completion, then it will be given to ready state. Then once it is in ready state, again it can be moved to a running state. So waiting state is nothing but it is waiting for some of the event to happen. Then once the event or the IO interruption is over, then it will be again send it back to the ready state. From ready state, it will move to the running state once it start execution. So if the process finishes its execution, then it will be terminated by the terminated state. Then exit will be called to terminate the process. Right? Now we'll see a different scheduling algorithm. So there are different algorithms are used to allocate a CPU time. So CPU scheduler can select processes from the ready queue based on a various scheduling algorithms. The different scheduling algorithms have different properties, and the choice of a particular algorithm may favor one class of a process over the another class. The scheduling criteria include CPU utilization, throughput, where the throughput is the number of processes which are completed per unit time, then the waiting time, the sum of periods spent waiting in ready queue, then the turnaround time, the interval between the time of submission of a process to the time of a completion. Then the response time, the time from submission of a request until the first response is produced. With this, we will see a different scheduling algorithms. So there are 5 types of algorithm: FCFS, SRT, then SJF, priority scheduling algorithm, and a round robin scheduling algorithm. Now we'll see a shortest job first scheduling algorithm, or shortest remaining time first algorithm. So here a SJF is an algorithm which process having the smallest execution time is chosen for the next execution. It significantly reduces the average waiting time for other processes awaiting execution. The full form of SJF is shortest job first. There are 2 types of SJF: non-preemptive SJF and a preemptive SJF. So we'll see what are the characteristics of SJF scheduling algorithm. This is associated with the job as a unit of a time to complete. The process will be completed as a unit of a time. Then this algorithm is helpful for batch type of processing, where waiting for jobs to complete is not a critical. It can improve the process throughput by making sure that a shorter jobs are executed first. So shortest remaining time is nothing but here the shortest burst time will be executed first. Hence the possibly have a short turnaround time. Because of this, we will get a turnaround time is also less compared to other algorithm. It improves the job output by offering a shorter time remaining of a burst time, which should be executed first, which most have the shortest turnaround time. Alright. So here the non-preemptive SJF. SJF preemptive algorithm, the CPU cycle is allocated to the process. The process holds it till it reaches a waiting state or a terminated state. Then consider some of the processes which having its own unique burst time and arrival time. Now we'll see how this shortest remaining time algorithm will be implemented with an example. There are a process queue, 5 processes are given. Then with the burst time, process 1 has an burst time as 6, 2 has an burst time is 2, process 3 has an 8, process 4 is 3, process 5 is 4. Then the arrival time of process 1 is 2, 2 is 5, 3 is 1, P4 is 0, P5 is 4. So now with this arrival time, the execution of a process will be carried out. Initially, process P4 is arriving in the CPU. So for the execution of a task. So P4, which has a burst time, is 3. So now we'll see how it executes. So here process in the step 0, at time 0 the process P4 arrives and start its execution. In the Gantt chart we have seen there are no process initially. When it at the time 0 the process P4 arrives for execution, and in step 1 the time T1 process P3 arrives, but P4 still needs to execute 2 units to complete its task. So it will continue execution for another 2 units. Then in step 2 at time T2 process P1 arrives and is added to waiting queue, and P4 will continue its execution. So here in step 3 at time 3 process P4 will finish its execution. The burst time of P3 and P1 is compared. So here P1 and P3 are having a burst time 6 and 8. Then P1 will get a chance to execute a process. Now at the next step, in step 4 at time time 4 process P5 arrives and is added to the waiting queue because P1 is continuing its execution. Then in step 5 at time T5 process P2 arrives and is added to the waiting queue, but P1 will execute, continue the execution. In step 6, at time T9, process P1 will finish its execution. The burst time of P3, P5 and P2 are compared. Now process P2 is executed because its burst time is a lowest one. So process P2 has a burst time as 2. So P2 will get a chance to execute the process now at the time 10. So P2 is executing and P3, P4 are in the waiting queue. In step 8, at time T11, a process P2 will finish its execution. The burst time of P3 and P5 is compared now to give a chance to execute a process. So process P5 is having a less burst time compared to process P3. So P5 will get a chance to execute in step 8. Then process in step 9, at time 15, process P5 will finish its execution. Then the chance will be given for the next process, that is at T time 23, only P3 is left out. So P3 will also finish its execution and the execution time of all processes will be considered as an 23. And here now we'll start calculate the average waiting time for the example. So P4 waiting is 0 because it has a arrival time is 0. Then P1 waiting time is 1 because it waited for the other process to release the CPU. Then process P2, that is 4, P5 is 7, P3 is 14 times. So average waiting time of this is 26, then divided by number of processes. So there are 5 processes, so total time is 26 divided by 5 is 52. So in this fashion we got average waiting time in shortest remaining time. So this shortest remaining time algorithm is implemented. Now we'll see the algorithm. So start the process, then accept the number of processes in the ready queue. Then in step 3, for each process in the ready queue assign the process ID and accept the CPU burst time. Then in step 4, start the ready queue according to the shortest burst time by sorting according to the lowest to highest burst time. Then in step 5, set the waiting time of the first process as 0 and its turnaround time as its burst time. Then step 6, for each process in the ready queue, calculate the waiting time for the process of n equal to waiting time of a process n minus 1 plus burst time of a process n minus 1. Then calculate turnaround time of a process of n equal to waiting time of a process of n plus burst time of a process n. Once we get a value of a turnaround time and waiting time, now we can calculate in step 6 our average waiting time. So average waiting time equal to total waiting time divided by number of processes. Then average turnaround time equal to total turnaround time divided by number of processes. Then step 7, stop the process. Right. So this is implementation of a shortest remaining time algorithm. So now we'll see the execution of a process, execution of a program. Now we'll see round robin scheduling algorithm, how it will be implemented. So round robin comes from the round robin principle. RR is nothing but a round robin algorithm. So where each person gets an equal share of something in turns. It is oldest and simplest scheduling algorithm which is mostly used for multitasking. So round robin scheduling, where each ready task runs turn by turn only in a cyclic queue for a limited time slash. This algorithm also offers starvation free execution of processes. Right? Now we'll see what are the characteristics of round robin. So round robin is a preemptive algorithm where the CPU is shifted to the next process after fixed interval time, which is called as a quantum time or a time slash. The process that is preempted is added to the end of the queue. The round robin is hybrid model which is a clock driven. The time slash should be minimum, which is assigned for a specific task need to be processed. Here it may differ from operating system to operating system. It is a real-time algorithm which responds to the event within a specific time limit. The round robin is one of the oldest and easiest algorithm to use it in the CPU scheduling algorithm, and it is mainly used for a CPU scheduling in a traditional way, and it is most famous one, a traditional round robin algorithm, and it is based on a some quantum size. So consider now the example. There are three processes P1, P2, P3 which has a burst time 4, 3 and 5. How these are executing? In a queue, all three processes will be entered. So initially P1, P2, P3. So then the time slice is given is only 2. Time slice for the processes are 2. Right, now we'll see how it is executing. In step 1, the execution begins with the process P1 which has a burst time 4. Here every process executes for 2 seconds. Then P2 and P3 are still waiting in a ready queue. Then this is a step 1. Now in step 2, at time 2, P1 is executed and the end of the queue, and P2 starts execution of in a ready queue, right? In next step 3, at time T4, P2 is preempted, and at the end of the queue P3 start execution. In step 4, at time 6, P3 is preempted, and at the end of the queue and P1 starts its execution. Right? In step 5, at time 8, P1 will be preempted and it has completed its execution. So P2 starts its execution. Now in step 6, P2 has a burst time of 3. It has already executed for 2 intervals. Here 2 intervals. At time 9, P2 will be completing its execution. So then P3 starts execution till it completes, because only P3 is left out. So already P1 and P2 are finished its execution. So P3 completes its execution. Then now after once all processes are executed, we can calculate an average waiting time and a turnaround time. So waiting time of a process is P1 waits for 4 seconds, then P2 waits for 6 seconds, P3 waits for 7 seconds. So the average waiting time is total time of a process, waiting time of process divided by n number of processes. So we got a value as an 5.6. Now P3, so we'll implement this using a round robin scheduling algorithm. Now we see the algorithm, how this will be generated. Now in this algorithm, first we need to accept the number of processes. So start the process in step 2, accept number of processes in a ready queue and a time quantum of a process. Then in step 3, for each process in ready queue, assign the process ID and accept the CPU burst time. In step 4, calculate number of time slices for each process, where the number of time slices for process n is equal to burst time process of n divided by time slice. Then in step 5, if the burst time is less than a time slice, then the number of time slices is equal to 1. In step 6, consider the ready queue, circular queue, which calculates a waiting time for the process of n equal to waiting time of a process n minus 1 plus a burst time of a process of n minus 1 plus the time difference is getting the CPU from process n minus 1. Then turnaround time of a process, waiting time of a process n plus burst time of a process n plus the time difference of a getting CPU from process n. Then once we get a waiting time and turnaround time, we can calculate a average waiting time as well as average turnaround time. So average waiting time is total waiting time of a processes divided by number of processes. Then total average turnaround time divided by number of processes will give a average turnaround time. So here we stop the process. Now we'll implement this algorithm for writing a round robin algorithm. Right, now we'll go for execution. So now we'll see how this will be executed. Let's execute the program 7. C program which has a scheduling algorithm, shortest remaining time and round robin algorithm, right? So now we'll create a file for lab7. So lab7 has a file name .c because it's a C program which consists of a structure. Structure has a process information which consists of arrival time, burst time, remaining time, waiting time and a finish time, as well as a round robin time. So when the process is accessed, the record of each process will be accessed through the structure of a process here. So there are two round robin algorithm, two scheduling algorithm, SRT and round robin. So we have used a switch to move the scheduling algorithm. So first choice is for round robin, second one is for SRT and third one is for exit. So with this we have written functions for each scheduling algorithm. So round robin which accepts the process burst time, then a quantum time. Based on a quantum, the process are going to execute in the CPU timing. So once the process finishes its execution, then the burst time, the CPU will be given to allocated for the next process. So in this way we are checking with the other algorithm, this is SRTF. SRTF is nothing but a shortest remaining time first. So here also it will accept number of processes, arrival time as well as a burst time. Based on arrival time, then the execution will be carried in the shortest remaining time, right? So now we'll see the execution of a process. So now we have to compile using C because it's a C file. So CC, then the file name lab7.c. It allows you to execute, then there are no errors. If there are warning, then it can be negligible. So now we can execute using ./a.out. Now enter the choice. So based on a choice, it will call the functions. So first we'll check with the round robin algorithm. So round robin scheduling algorithm. So it asks you to enter the number of processes. So there are 3 number of processes. Then the burst time of all 3 processes are, first process has a burst time is 24, the second one is 3 and third one is 3. Then a quantum time of slash is 4. Then now if you press enter, then it will give you the average waiting time of a process and average turnaround time of a process. So here a process which has a burst time 24, 3 and 3. So quantum size is given as 4. So here 4 means first process will execute for 4 burst time. So from 0 to 4, the first process will execute. Then after that, once it executes in a cycle, then it will move, the CPU will be given to the second process, that is which has a burst time as 3. So it finishes the execution of a process completely, then it gives it to a third process, that is process 3, which waiting time is 7. Then it executes, it finishes its task, and then again CPU will be provided for the process 1. So process 1 has a 20 minutes of a burst time. So here this 20 mm will be executing in a full complete process. So once it start execution at the time 10, then once it finishes its execution at the time 30. So once it overs, then it will come out of the process, and here we can calculate a waiting time, turnaround time and an average time and average waiting time. So a Gantt chart which will be drawn for using a burst time as well as a waiting time. So here waiting time of a process 1 is 6 because it waits for a second cycle and third cycle, that is 3 burst time and 3 burst time. So totally 6. So waiting time of process 1 is 6 and the waiting time of process 2 is 4 because first cycle P1 will execute, and process 3 has a waiting time as 7 because process 2 has to execute. So totally 7 minutes it waited in the CPU cycle, right? Once it overs, then the turnaround time is called as a completion of a process execution. So P1 completes the execution at the time 30. Then P2 completes its execution at the time 7. So P3 completes its execution at time 10. So here turnaround time is 30, 7 and 10. So adding this and dividing by 3, we'll get turnaround time, that is 15.6, and average waiting time is total time of processes divided by number of processes. So we got 5.6. So it is correct. Now we'll move to the second one, that is shortest remaining time. So now we enter a choice 2. So in the shortest remaining time, we'll enter number of processes. So the number of processes are 4. Then arrival time of first process is 0th time, and burst time of this is 8. Then process 2 arrives at 1 time, and then process burst time is 4. Then process 3 arrives at a time 2. Then burst time is 9. Then process 4 arrives at a time 3. Then burst time is 5. So now we'll see what is the arrival time, burst time, waiting time, finishing time, and a turnaround time. So same thing here. So burst time, based on a burst time and arrival time, the waiting time will be calculated and turnaround time will be calculated. So the average waiting time is nothing but total turnaround time divided by number of processes, and average waiting time is total waiting time divided by number of processes. So here we got average time is 13, and average turnaround time is 13, and average waiting time is 6. So this is a shortest remaining time. So now the third one for exit.